Alright friends, so here is a class on about addition subtraction with different denominator. So in this class it shall be giving us an extensional arithmetic skill which will be actually discussing about LCM in addition to what we'll be doing in additions of fractions with different denominator. So ensure you pay very good attention and you will love this class. So at the same time, ensure you're subscribed as said so that you continue in everything we are doing. Alright. So example 1, let's assume we're given something like this. We're given 4 over 5 plus 2 over 3. 4 over 5 plus 2 over 3. Now in this case, we can't just choose any one because here we have 5 and here we have 3 as a denominator. So they are different, so this calls us to do what we call the LCM of 3 and 5. So taking 3 and 5 into a tabular form, put a 5 here, put a 3 here, and draw a table cross. So this least prime number we can start with is 2, but 2 will not divide this number completely. It will have a remainder, so we're not going to use 2. Let's move to another next prime number, which is 3. Okay, 3 exists here, so we can use 3. So 3 in 5 is possible but not possible because it will have a remainder. We don't want a situation by the remainder because we don't have where we are going to write the remainder. So if it's not going to divide it without the remainder, then we ain't using it. That is why we use the word is impossible. Mathematically it's possible, but in dealing with LCM, we will consider it not possible because we want a situation whereby it will divide without a remainder. So 3 in 5 will be possible in this case, or it will have a remainder, so we're going to ignore it and drop the 5. That means we're ignoring it, so we drop down the same 5. So 3 in 3 in this case, 3 will divide 3 one time. So the only significant number we have here is 5, so we're going to use 5 next our next prime number to divide. So 5 in 5, 1. This one is already finished, which is 1. So we have, so multiplying all our divider, we have 3 times 5, which will give us 15. Now LCM is 15, so we are integrating these denominators to become 15. So 5 times 1 is going to give us 15. We say it is 5 times 3. So checking the multiplication table, you see that 5 times 3 is equal to 15. So in this case, we say 5 times 3 is equal to 15. So this times 3, this multiplier, we're going to raise it to the numerator. We put it right here, which is times 3. So same thing apply here. 3 times 1 give us 15. 3 times 5, we put times 5. So this multiplier, we raise it up to the numerator times 5. So now 4 times 3 is 12 all over 5 times 3 is 15 plus 2 times 5 is 10 all over 3 times 5 is 15. So in this case we already have them on the same denominator, so we can just work with the way we did our initial additions of fraction with the same denominator. So now we've made them the same denominator, so it's easier to continue. So same denominator, you choose any of or either of them, which is 15. So we have 12 plus 10. So 12 plus 10 will give us 22 all over 15. So 22 all over 15 is an improper fraction, so we need to make it look more better. So we are going to use 15 to divide 22. So 22 divided by 15 will go one time because the second place of 15 is 30. So 22 is not for 30, so it's going to divide one time. So from 15 to 22, what's the distance between 15 to 22? The distance between 15 to 22 is from 15, count to 22, 15. 16, 17, 18, 19, 20, 21, 22. So we counted an extra of 7 numbers. So the remainder is 7 all over our denominator 15. And that's our answer. And that's correct. So example 2, Let's assume we're giving 2 over 3 plus 3 over 6. So 3 and 6 are different number. They are not the same number, so we need to do the LCM of 3 and 6. But for me, according with my own intuition, I can say the LCM of 3 and 6 is 6. Why? Because 3 exists in 6, so I can integrate 3 to become 6 by checking what multiplier I'm going to use to multiply 3 to become 6. And we say 3 times 1 give us 6. We can say 3 times 2 is equal to 6. So in this case, I can just come here and say, since I can integrate 3 to become 6, by what number am I going to multiply it? I'm going to multiply it by 2. So 3 times 2 can be 6. So this multiplier, I'll raise it up to the numerator times 2. Don't forget, at all means, by any means, at all costs, don't forget to raise the multiplier to the numerator. I'm signing this Vietnam so that you should know that and put that at the table of your heart. It means put that a reminder at always. I've seen a lot of students physically and online. Once they just multiply the denominator, they will just by over-excitement, over-confident, forget to raise the multiplier to the numerator. You must always raise the multiplier to the numerator. So, because that are done, to make this more provingly that the LCM of 3 and 6 is 6, we can put it right here. 3, 6. Now let's do the LCM of 3 and 6. So we have, so what prime number can start? We can start with 2. So in 3, impossible drop out 3. So in 6, 3. Then we can use 3. 3 in 3, 1. 3 in 3, 1. So we have 2 times 3 equals to 6. So in that case, so let's continue. Since we know our SM is 6, so this is already 6. We are not integrating this one because it's already at the point it's supposed to be. So it's only this one that needs to become 6. So it will be 3 times 2 to become 6. We raise the times 2 up to the numerator times 2. So 2 times 2 is 4. All over 3 times 2 is 6 plus 3 over 6. Now they are the same denominator. So that is equal to all over and either of the denominator, which is 6. So we have 4 plus 3, which is equal to 7 over 6. 6 can go in 7 one time. From 6 to 7, the distance is 1, so the remainder 1 over denominator 6. And that's correct. So number 3, let's assume we're giving 2 over 7 plus 3 over 14. So LCM of 7 and 14, who can quickly tell me? Okay, you there? Yes, it is 14. The LCM of 7 and 14 is 14. Why? Because 7 exists in 14. By how many times? By times 2. 2 of 7 is 14. So we can equally integrate 7 to become 14 by giving it a multiplier of by 2. So you can say 7 times 2 will give us 14. So raise this times 2 up to the numerator times 2. So from here we can say 2 times 2 will give us 4. All over 7 times 2 is 14 plus 3 over 14. So what we have next here is, since they are same denominator, we choose n, which is 14. So we have 4 plus 3. 4 plus 3 will give us 7 over 14. So we can say this is our final answer, or we can break this fraction down to its least form. What possible number can go in 7 and can go in 14? Yes, 7. 7 can go in 7 and 7 can go in 14. So 7 in 7 will go one time, 7 in 14 will go twice. So we have it as 1 over 2 as our final answer, and that's correct. Alright, so let's take our next example, example 4. Let's assume we are given a fraction of 2/7 plus 2/5 plus 3/10. So in this case, what we're going to do right here is we're going to take the LCM of 7, 5, and 10. So the LCM of 7, 5, and 10. So let's draw them in tabular form. So what number can go? The least prime number that can go is 2. There's 2 in 10. So we can use 2. 2 will not go in 7 completely. So we'll drop our 7. 2 will not go in 5 completely. So we'll drop our 5. 2 will go in 10 completely. That is 5 times. So the next smaller prime number here is 5. 5 will not go in 7 without the remainder. So we're going to drop 7. 5 will go in 5 completely, which is 1 time. 5 will go in 5 completely, which is 1 time. So the next prime significant number here is 7. 7 is 7, 1, 1, 1. So multiplying our dividers, we have 2 times 5 times 7. So 2 times 5 is 10. 10 times 7 is equal to 70. Then 5 times 7 is 35. So 35 times 2 is 70. So next thing we're going to do here, we'll check them. We'll say 7 times what will give us 70. Since our SCM is 70 here, we'll come back right here and say 7 times what will give us 70. So it's 7 times 10 times 10. 5 times what will give us 70. 5 times 14 times 14 times 14. 10 times what will give us 70? 10 times 7 times 7. So we say 2 times 10 is 20 plus 2 times 14 is 28 plus 3 times 7 is 21 all over 70, because all of them is 70. This is 70, this is 70, this is 70. So same denominator, we choose any. So 20 plus 20 plus 20 is 60. 20, 40, 60. 8 plus 1 is 9. So we have it as 69 over 70. So it's a proper fraction. That's be our final answer, and that's correct. So let's take our last example. So our last example in this case will be having 3 over 9 plus 2 over 7 plus 2 over 3. So let's take 9, 7, and 3 into LCM. So what least prime number can we use here? 2 will not go in any of them, so we can continue with 3. 3 in 9 is 3, 3 in 7, it will go but not complete, so we're not going to divide that. We drop it. 3 in 3, 1. Next prime number can use is 3, 3 in 3, 1, 7 will drop 1. Then the next significant prime there is 7. 7 in 7, 1. So we have 3 times 3 times 7. So 3 times 3 is 9. 9 times 7 is 63. Then 7 and 3 is 21. So 21 times 3 is 63. So 9 times what will give us 63? Our SCM is 63. So it will be 9 times 7 times 7 times 7. 7 times what will give us 7 times 9 times 9 times 9. 3 times what will give us 63. 3 times 21 times 21 times 21. So next one we have is times 7 times 7. 3 times 7 is 21 plus 2 times 9 is 18 plus 2 times 21 is 42 all over 63. So 20 plus 40 is 60. 1 plus, okay, let's say this 2 plus this 8 is 10, making 50. 50 plus this 10, making 60. 60 plus 20, 80. 80 plus 1, 81. So this is 81 over 63. So 63 can go in 81 one time. Then from 63 to 81, what's the distance between 63 to 81? 63, 73, that is 10. I counted in 10. 63 to 73 is 10. So I'll keep that 10 in my mind. Now 73 to 81. 73, 74, 75, 76, 77, 78, 79, 80, 81. So I counted the extra 8. 8 plus that 10 I counted off. That's 18. So remainder 18 all over 63, which is our denominator. So that's the final answer, and that's correct. So at this point, I believe we have understand how to add fractions with different denominators. So if you have any questions, ensure you write your question in the comment section below. I'll be very willing and happy to answer every of your question promptly. So at the same time, ensure you subscribe to the channel. If you love what you've seen, hit that subscribe button, notification, like, and also drop a comment. Bravo, thumbs up. It's very essential. So thank you. So we're going to meet in the next class. In our next class, we shall be discussing about subtraction of fractions with same denominator and more into different denominator.